In this work, we present Triplet Attention, a lightweight attention module for computer vision. The idea of using attention mechanisms in computer vision is not new. The squeeze excite layer introduced the idea of modeling cross-channel information through a module that learns weights for each channel in a 3D input tensor. CBAM later extended this idea to include a separate module that performs similar computations but across the spatial dimensions. Using both the channel weights and the spatial weights together allows this module to generate a more refined attention mask across the input. Global context networks added a non-local block to the pipeline, allowing it to capture long-range dependencies or global features more effectively. However, the existing methods have some shortcomings. They all treat the channel and spatial dimensions independently, introduce a non-trivial computational overhead on common vision models like ResNet 50, and use some form of a bottleneck design that can result in a loss of information. Apart from being more computationally efficient, our goal was to design an attention mechanism that incorporates the idea of cross-dimensional interaction. The standard 2D convolutional layer, widely used in computer vision, can effectively learn features across the two spatial dimensions, height and width. To incorporate the information across the channel dimension as well, we can permute the input tensor into three different configurations by shuffling their axes. Then, any standard 2D convolutional based transformation can be applied to each of these configurations independently. Full cross-dimensional interaction would allow the model to understand complex relations between different positions in an image. The model could learn that the important spatial region of one particular channel is the top right, but that in another channel, the bottom left is perhaps more important. This idea could be useful in, for example, tracking the motion of an object through time, where the channels represent frames of a video. Our proposed method is called Triplet Attention. Triplet Attention is primarily composed of standard convolution and pooling layers that are well optimized and efficient. These layers are put together with batch norm and a residual connection to form the transformation that we apply to each permutation of the input tensor. The resulting output generated by triplet attention has the same shape as the input, which allows it to be easily integrated into existing models without any other architectural changes. The architecture of triplet attention itself can be visualized using a three-branch structure. Each branch takes in a unique rotated copy of the input and applies the transformation to it. The three resulting outputs are then broadcasted back to the original shape and averaged to form an attention mask. The attention mask is multiplied element-wise with the input to produce refined features to pass on to the next stage of the network. Our experiments show that triplet attention effectively improves performance without introducing a significant increase in computation. For image classification on ImageNet, triplet attention outperforms most other methods while introducing the least number of extra parameters on a ResNet 50. When using the same ResNet 50 backbone augmented with triplet attention on a mask RCNN model, our method demonstrates a strong increase in performance on the COCO dataset while introducing a negligible number of extra parameters over the baseline. We further validate our results by examining the GradCam heat maps generated by a model trained with triplet attention. Triplet attention consistently produces tight and accurate bounds over the correct object in the image. We also observed that when required, these bounds are able to dynamically morph and adapt to irregular shapes and patterns in the image. For more information, please visit our website where you can find the paper, code, and pre-trained models. Thank you.